Number 1, write an expression that would represent the measure of one of the base angles of the isosceles triangle. So this is left over from last unit, and then this next one will be an introduction to this coming unit. There's your answers. Good. All right, so we know, first of all, that the base angles are congruent. We know that by the isosceles triangle theorem. That was one of the things on your test. Remember that? All right, so we know that these are congruent. Now, what would be wrong, and what I've seen students do before, is they call those x. You can't call those x. You cannot call those x because x is already being used in the problem, and you don't know that those angles are actually, they equal the value of x. So that would be an incorrect way to approach this problem. But what you can do is think about the triangle sum theorem and the fact that you know that those two angles represent, they represent 180 minus the vertex angle. That is the sum of those two angles. It's two angles. It's 180 minus 2x. Then you know that those two angles are congruent, and so we can do that right there. We're not done. This can be simplified. So we're going to do 180 divided by 2, which is 90. And we can do 2x divided by 2. So look at that. Each angle equals 90 minus x. What's another word for that? Who knows another word for 90 minus x? 90 minus x is a complement. Yes, it is. It's the complement of x. Cool. That was good. Okay, it doesn't mean that there's a right angle in this diagram. I didn't want you to think that, but the measure of the base angles is the complement of x once you know what x is. Okay, which statement must be true? All of these statements could be true, but there's only one of them that must be true, and it's actually called the reflexive property of equality, which we're going to use a ton in this unit. What's the answer, guys? Because this figure has no markings, no tick marks, no arcs on the angles, the only thing we're allowed to assume is literally that that segment equals itself. RT equals TR. That is the only thing that we are allowed to assume, that a segment is congruent to itself, which is always true no matter what the picture looks like. And that is actually called the reflexive property of equality, and it is a paramount property in this unit. Get out your notes and call it congruent figures. Congruent figures. Why am I showing pictures? What does this have to do with congruent figures? They are all identical twins, exactly. So, what does it mean for figures to be congruent? You can write this down. Congruent figures will have the same size and the same shape. So when two figures are congruent, one will fit exactly on the other. You can slide it, flip it, or turn it, and there should be no overlap. Well, it should completely overlap the other. There should be nothing sticking out in the background. So a translation, that's what this is, a translation, a reflection, and a rotation. Those are all transformations that will get you congruent figures. The transformation that would not result in congruent figures would, of course, be a dilation. A dilation is when you enlarge or reduce a figure. So that's going to be changing its size, and so that would not produce a congruent figure. So you can map a figure to a congruent figure using translations, reflections, or rotations. I just wanted to show you a few examples of congruent figures in the real world. Here's some congruent pentagons. The shuttles are old news now. NASA doesn't even use these shuttles anymore. They have a whole new program with different space vehicles. But anyways, on this one, it was just cool because there were some congruent pentagons, 5-sided figures that were congruent. And it's really important that whoever designs this knows about congruent figures. There has to be a lot of symmetry here or in any aircraft. And And so what if the person on the job didn't understand what it meant to be congruent, didn't know how to check if two figures were congruent, didn't know which measurements to look at? So that could mean bad things if they weren't trained correctly. Some more congruency in the real world. This is at the Air Force Academy, I believe. Isn't that a pretty building? It's a chapel on their campus. Look at all those congruent triangles. Isn't that just beautiful? Yay, geometry and architecture. And then we have bridges. Bridges often have supports that are congruent figures, sometimes congruent triangles, like in that picture right there. All right. Which triangles are congruent? How do you know? So what would it mean to be congruent? What would you need to check? What would be true if two figures were actually congruent? They can't just look similar. That's the next unit called similarity. They can't just look the same. They have to perfectly match every aspect of them. That's a suggestion. You could slide them or rotate them and line them up and make sure that they line up perfectly. So for example, I could take this gray one and I could kind of drag it around. Are those two figures congruent? No. Are those two? No. Which ones do we think match? They would need to perfectly line up. No. No. Ding, ding, ding. We found a matching one. All right, let's see what's going on here. Oops, didn't rotate it perfectly. Ding, ding, ding. So this guy was the odd one out. He doesn't have a twin. Anyway, so one of the ways is we could line them up. But you're like, Miss Tanton, we don't have smart boards on our desks. How could we do it? Well, how could you do the same thing I did on your desk? Measure them, Kendra said. Use a ruler, a protractor. Maybe not fold the paper, Ralph. Where else could you go with that? Starts with P. Yay, TJ, patty paper. Yes, you could use patty paper. You could trace one of them, and you could drag the patty paper around your page and see which ones line up perfectly. So there's multiple ways that we can check to see if two figures are congruent. All right, you may write this definition down. Congruent triangles, and this is really true for congruent figures in general, but two triangles are congruent if and only if the corresponding sides and the corresponding angles are congruent. So okay, so you're writing this down in your notes. What does it mean? You know, a definition is only good to us if we know what the words in the definition mean. Two triangles are congruent if corresponding sides and corresponding angles are congruent. What does corresponding mean? So we need to figure out what that means. Relating, that's a good word. The ones that relate to each other. The ones that go with each other. So if I were to draw a triangle, or no, let me just draw a figure, because we're going to spend plenty of time talking about congruent triangles later. On a keyboard, how would I create a congruent figure of this trapezoid or quadrilateral? How would I do that on a computer keyboard? Oh, that's true. I guess I could use the snipping tool. Yeah. I was thinking about Control-C, Control-V, right? So if I select this and I go over to my keyboard and I do upside down, sorry, Control-C, Control-V, that will give me a congruent figure. Now, these are congruent if the corresponding angles and the corresponding sides are congruent. What that means is that you just can't compare any of the parts you feel like. You can't say, oh, because these are twins, this matches this. That doesn't make logical sense. You have to match up the sides that go together, aka correspond with one another. So this side is going to match up with this side because they are our corresponding parts. So that's what that means. Corresponding means the ones that match up, the ones that go together. That's what corresponding means. All right, please do not put this in your notes. You can just watch. Put this part I do want you to put in your notes right here. I want you to write this in your notes and then write down what that is called. That is called a congruence statement. Congruence statement. The great, wonderful, fabulous thing about a congruence statement is that it's not allowed to lie. A congruent statement always tells the truth. This time, every time, all the time. So even though the picture can lie, you know how our figures are not always drawn perfectly to scale? The picture can lie, so don't just use your eyes, but the congruence statement can never lie. So you're allowed to trust the order every time. For example, if I just threw down some letters here, C, A, E, and then I asked you to finish the congruent statement. Angle C is congruent to angle blank. Well, looking at the picture doesn't really give us a lot of insight. Which angle matches angle C? I don't know. They all kind of look similar in size. If I had a protractor, I could do that, but I don't. So what I'm going to do is go look at the congruence statement. C is listed third. What angle is listed third? In the other triangle, F. So we know angle C is congruent to angle F because it's listed third and listed third. So on and so forth. Angle A would be congruent to angle D, and angle E would be congruent to angle B. Where am I getting those from? I'm getting them from the statement. Now, I would want to put markings on my picture if I needed to solve my problem. So I could go to angle C and add an arc. Let's not use that color. Add an arc and an arc. I could go to A and add a double arc, and then 1, 2, 3, triple arc, triple arc. So I could indicate on my picture which angles were congruent, and then it helps me see what happened to my triangle. It just got rotated, right? Translated and rotated a little bit, but it's still the same triangle. All right. Now let's look at sides. Let's list the congruent sides. So I'm going to list some sides, and I want you to try to list the ones that are congruent to it. All right, so Yang got FE. CB is congruent to FE. Let's see. CB is listed third, second. So I would go to my other one and list what's third and second. So that's perfect. Those correspond with each other. Very good. I could add tick marks to my picture. CB is congruent to FE. DF is listed first and third. What else is listed first and third? DF. This one was AC. Good. So tick marks, double tick marks. Lastly, we have BA, and that would be congruent to ED. Now, let's talk about order real quick. Let's talk about order of the letters really quick. In a congruence statement of triangles, in a triangle congruent statement rather, the order absolutely positively matters. It's a huge deal. Now, when you're listing segments down here, the order does not matter because segment, let's say FE, is the same exact segment as segment EF. So if you had put EF, it would not be wrong, even though your order is different than the congruent statement. A segment is a segment. Okay? All right, so now we're going to do the opposite. I'm going to give you the pictures with the markings on it, and I'm going to ask you to write the congruence statement. Now, you can start with whatever order you want, but I don't want us all to have different orders or else you can't compare your answer. So I'm going to put the first one for you. I want you to think about what triangle UNT is congruent to. And the order on this one is going to absolutely matter. So think about in your head what triangle is congruent to triangle UNT, and be careful on your order. So how do we do a problem like this? So first you need to look at the triangle that was already named. UNT. So I went from U to N, and then from N to T. I went across 3 tick marks and then across 1 tick mark. So it's really important which way you named it. For the other one, I need to name it in the same way. I need to go across 3 tick marks and then across 1 tick mark. So I would name it G-E-M. UNT is congruent to G-E-M. I have to go in this corresponding way. You have to make sure that they matched up. Okay? Let's try another one. Now, what's really great is when the angles are marked, because when the angles are marked, it's even easier to name them. I'm going to name the first part, and you finish it off. Triangle YZX is congruent to, okay, Kendra said NLM. So what I love when I give you, like I said, angle markings, you don't have to draw those like arrows like I did. You can just look at the arcs. No, I'm talking about this way too much. This is too easy. Y has 2 arcs, Z has 1, and X has 3. So we want to go 2, 1, 3. So we go over here to the one with 2, and then the one with 1, and then the one with 3. NLM. Very good. Given triangle ABF is congruent to triangle CDE, find the missing measurements. Since we know that congruent triangles have congruent corresponding parts, we can use that knowledge to find missing sides and angles. So what we're going to do first is we're going to look at what they're asking for, and we're going to find which one is congruent to AB. AB is listed first and second. CD is listed first and second. So CD is congruent to AB. If CD is 6 centimeters, then AB is 6 centimeters. The measured angle ABF. Now, since these triangles only have, oh goodness. All right, so angle ABF, since there's not more than one angle at each letter, we can just look at the middle letter. So we're really looking for angle B, and we know that that is going to be congruent to angle D because they are both listed second. Now we have a problem because we can't find angle B or angle D because we don't have enough angles in our triangle. But we can use the fact that angle A is congruent to angle C, and we can put the 28 here, or we could have put the 85 here. And then we can use Triangle Sum Theorem, and we can find the missing angle. All right, so Triangle Angle Sum Theorem says 67 degrees. Easy as that. If ABC is congruent to DEF, and the measure of angle B is x plus 40, E is 2x minus 10, and D is 40, solve for the missing values. So let's put these on our picture and see what we have going on. So we have x plus 40, we have 40, and we have E, 2x minus 10. Now, the question is, here's one of two things could happen. Either two of these equal each other, and we're going to set them equal, or none of them equal, and we're going to use Triangle Sum Theorem and add them up to equal 180. So let's find out. Which one matches angle B? B is listed second, E is listed second, so B matches E. Do you see how that works? Just because you're given 3 things does not mean you add all 3 things up to equal 180. You have to see what you're given and what makes sense for that problem. So the equation is x plus 40 is equivalent to 2x minus 10. All right, so here are the answers we got. So y'all got, let's see. X is 50. Okay, add 10 to both sides. Subtract x from both sides. Very good. All right, the measure of angle E. So we'd want to take 50 and plug it in here. 2 times 50 minus 10. So that would be 90. So that was a right triangle, not drawn to scale. Okay, and then angle F. Angle F goes with angle C. Angle F goes with angle C, so we need to find the missing angle. So if this is 90 and this is 40, we can add them up and subtract from 180, and yes, you will get 50. Moving right along. Let's name the congruent statement. Okay, I will call this FBR. FBR is congruent to what? Okay, so when I named that, I named the 58, then the 90, then the, I guess we could find the missing angle, what, 32? So I need to name the 58, the 90, then the 32. Even though these are overlapping, you can still do that. That's not 320. There you go. So I'm guessing if this is 32, then that's our 58. So I'm going to name the 58, the 90, and then the 32. Earl. Faber is congruent to Earl. I like trying to say words out of the names of the triangle. Okay, so let's find the measure of these angles. I think we found most of them. FRB. FRB is 32 degrees. We're running out of time, which is why I'm speeding up. LEB, be careful. You have to be able to find angles when we name them with 3 letters. LEB would be the linear pair of 158. Am I doing that right? Nope. 122. Yep. And LRF would be this angle right here. It would be the complement of 32. 90 minus 32. So it would be 58. Because this is a right angle and we have 32 already used up. So sometimes your triangles will be overlapping. This is the last slide. Remember those district questions they love to ask, which of the following is not true? So I want you to find the statement that is false. If pentagon paint is congruent to pentagon house, find the false statement. AT is congruent to EO. AT is listed second and fifth. EO, second and fifth. So that one's true. A is congruent to O, listed second. True. AI is congruent to US. Uh-oh. This is second, third. This is third, fourth. So here we found the one that is false. So remember, a congruent statement never lies. You may trust the order of the congruent statement every time, all the time. Sorry, one more, an addendum. I thought we were done, but we're not. On your homework, there'll be 3 problems where you have to find the missing coordinate. You want to force these quadrilaterals to be congruent, and D is not plotted, and you want to find out where D falls. The answer is slope. You use slope, and you use the figure that you're already given. So you can either figure out, how do I get from Q to T? And you can start at A, and you can go the same way. You could also say, how did I get from S to T? And you could go the same way. We know that T corresponds to D, so that's the one we want to keep our eye on. Where does T lie in reference to Q? And that will help us find where D lies in reference to A. So to get from Q to T, I go down 1, 2, 3, 4, 5, 6. So I go down 6, and I go left 1. So I'm just going to do the same thing. I'm going to go down 6, 1, 2, 3, 4, 5, 6, and left 1. That would be my coordinates of D. So the answer to the problem would be 3, negative 2. And that's how you would find it using slope.